So we would like to sketch the level curves of the function f of xy equals x squared minus y that correspond to the values z equals 0 and z equals 1. It's a good idea to first recall what we mean by that. So let's say that we have a function of two variables, and we have a number c. Then we consider all the xy's, meaning all the inputs, for which the output is equal to c. There are a couple of ways to visualize this. Maybe the best one is to think of the graph of the function f of xy as a surface, and then intersect. Let's see if we can sketch something like this. So imagine that the graph of this function is considered to be a surface, and then for z equals c, we consider the plane that goes through C, the horizontal plane that goes through C, and we intersect that surface along a certain curve. Let's say in this case it might look like this red curve, and that gives all the points, that corresponds to all the points for which the output is C. Why? Because the output is reflected by the Z value on the graph. We shouldn't forget that the graph is given by z is equal to f of xy. So if z is set equal to c, you find all the points that are at height at height c. Excuse me. And in some sense, the level curves allow us to visualize the graph of the function in a two-dimensional way. It's like a geographical map where you try to perceive the shape of the mountain by looking at areas that have almost the same height. So if you paint them with different colors, you can almost visualize the mountain from above. That's pretty much how the level curves work. So in this particular problem, we would like to actually sketch two specific level curves. And the general idea here is that level curves corresponding to values that are close to each other should be expected to look very much alike. Okay, so what do we do here? So the first level curve for z equals 0 will be given by the set of all xy's such that f of xy, and we know what f of xy is, it's x squared minus y, is equal to 0. So what we should focus on is this equation. That will define a curve on the xy plane. And of course, this curve is none other than y equals x squared. So we can easily sketch this curve. This is our usual parabola. So this is y equals x squared. And then for z equals 1, we will consider again all the xy's such that this time x squared minus y is equal to 1. And now if we play around a little with this equation, we will realize that this is y is equal to x squared minus 1. And so this corresponds to c equals 0, I should have said before. And x squared minus 1 is going to be the same curve, pretty much shifted downwards by 1. Okay, so this is y equals x squared minus 1. And this is the level curve for c equals 1. Or I shouldn't have changed the the notation here, I could have written for z equals 1 right here to make sure that we avoid any confusion. So z equals 1 and z equals 0. And that's it. I mean, for this particular function, if we continue to sketch more level curves, we would realize that they would all be parabolas that are shifted vertically. In some sense, we could think of these parabolas as describing what the graph will look like from above if we could visualize them at different heights. And that's all. Thanks for watching.